Good morning, Taipei. How are you all doing? Good. Welcome to Keysight World 2018. It's an honor and a privilege to be here today to address this audience. You guys are all going to make 5G a reality, and I'm really excited to be here today to share some of our perspectives on 5G and the journey that Keysight has been with the industry to bring 5G to reality. You know, it's a great time to be here, right? Especially on the cusp of 5G commercialization. I don't think I would have said that even last year. It feels appropriate to say that we are on the cusp of 5G commercialization today. Wireless technology is connecting everything, everybody, and everywhere. We have new emerging technologies. Donna alluded to a few of those, from smart clothing to smart cities, with billions of devices connected and exabytes of data generated and consumed every month. So really, the industry is progressing forward. The opportunities are immense, and we're here to help make this vision a reality. So that's what I'm here to talk about, and let's have some good dialogue here. So if you look at the commercial communications industry, mobile technology has fueled growth probably over the last decade and is expected to continue for many more years to come. 63%, more than almost 2/3 of data traffic, is expected to originate from mobile devices by 2021. And more than half of that data is video-based data, which means that it presents a significant opportunity to service providers for extracting more value. Then there are new types of services, like mobile augmented reality, that's expected to generate another $80 billion by 2022. The push for applications and devices that can provide more real-time, immersive experiences to the user. And then you look at IoT, the growth is even more. 36 billion more devices, and depending on who you talk to, that could range from anywhere from 25 billion to 100 billion connected devices by 2025. All of this means lots of opportunities and lots of challenges as well. 5G is expected to generate $1.2 trillion for the wireless industry in the next decade. And we're here to help. We're here to help make this a reality. So let's step back and talk about what the new network might look like, right? So today we live in today's network, the 3G, 4G network. Mobile data was a great addition to 2G and 3G. It works well most of the time, right? How many of you are happy with the service that you're getting, the data coverage, the speed, and the reliability? I, for one, am not. There's a lot of opportunity still, right? That network providers, device makers can all improve upon. And this is what the next generation communication system brings. We have Wi-Fi, we have cellular, we switch back and forth, but you need to know exactly which network you're using. And sometimes we know as we transfer across cell boundaries, operation is not as good. It's unreliable at best, and sometimes just doesn't work. And services, cellular services, especially in a crowded setting like this, or in stadiums and so forth, that leaves a lot to be desired as well. Not to mention, today's network uses almost 2% of the world's generated power. That's a lot, and it's fairly inefficient. Now, if you focus on tomorrow's network, it really is fueled by a massive increase in capacity through small cells, dense small cells, and more infrastructures for great service in a crowd. Millimeter wave addition is a welcome thing for 5G. You look at these beams needed to provide the type of data rates that new users of the next generation network are going to need. 100 times more data than what the current networks can provide. Up until now, millimeter wave has only been used in radar, point-to-point links, and aerospace defense. And it's really exciting to see millimeter wave technologies getting deployed in 5G in the next generation network. Then you have many, many things communicating, right? So you look at the car over there is got a nomadic base station at the top, and it's serving a user in another cell. The driver of the car itself, he's being served by a small cell, and the car is connected to the network for traffic guidance, collision avoidance, and mobile advertising. This is the reality of the next generation network. And for this, we know the key is in centralized and virtualized server-based networks. You've got to have the software in these huge virtualized network servers to apportion the network resources very effectively. Power, spectrum, data capacity, and computing, right? So it's not just UEs becoming smarter, IoT type of devices, augmented reality, but the network architecture has to change pretty significantly to make 5G happen. So whatever you're focused on, whether you're focused on flexible networks to provide the new type of services that 5G promises to offer, or whether you're focused on lower latency to provide more of an immersive real-time experience like mobile augmented reality, or you're focused on higher reliability for mission-critical applications, 5G is going to require massive innovation. And I would say we are well on our way of solving many of the challenges through our work with the industry over the last 4 years. So now that sort of sets up what the vision of 5G is and how it contrasts with the current network. So let's talk about what the standard bodies are doing. So much like legacy technologies, 5G is also expected to progress in stages. So we had release 15. We actually are going through release 15 right now. The phase 1 deployment of release 15 will actually occur in June, right? After release 15, we have release 16 that is expected to complete in December of 2019. So release 15 is going to form the basis for the first phase of 5G trials and deployment. And the next phase after that will be based on release 16. In fact, the first drop of release 15 occurred in December 2017. This is the non-standalone version of 5G. And the second drop is actually happening as we speak. It's going to complete this month. And that's going to focus on the standalone mode of operation for 5G. So clearly the standards bodies are doing their part in progressing 5G. I would say the pre-standards 5G, also known as 5GTF, that was trialed and deployed last year, helped accelerate some of the 3GPP 5G NR work. So good progress there from a standards body perspective. The other thing that I would say that's different in 5G compared to 3G, 4G is this concept of trials. 5G, we know, is technologically more complicated, and it promises to offer many more services and applications than older wireless technologies. So everybody wants to see what this is about, right? Operators want to see what type of services can be offered, how they can be monetized. They also want to see if we can overcome the technology challenges in a more cost-effective way. Device makers want to make sure that devices can be effective and not power-hungry. Nobody wants that, right? So there's energy around the ecosystem to push forward with trials, a lot of trials, unlike previous wireless generations. So usually it's come up with a standard, and then operators will have their own carrier acceptance tests on top of the standards. Now we see an additional step. There's trials, there's standards, and then there's post-standard carrier acceptance-based deployments. So we've seen this with Korea Telecom, showcasing some 5G technologies in the Winter Olympics that just ended in February. We saw Verizon in the US deploy fixed wireless networks based on pre-standards 5G. AT&T and Verizon have indicated that they would have many more of these trials and early commercialization towards the end of this year, early 2019. In Korea, spectrum auction is happening this month, and SK and Korea Telecom, they're looking to commercialize 5G in early 2019. China is pushing 5G very hard. Next year, there are going to be trials across 17 cities. 5 of those cities will have macro trials, and 12 of those other 12 cities will have many trials, including trying out new services. So clearly, there's a lot of activity here where the industry is wanting to deploy 5G to see value that can be extracted and also to overcome technology gaps and complexity. So with that, I think we can really say the 5G landscape is forming. Many of these ecosystems have already formed, others are still in process, and you can see that it spans the entire spectrum from 600 megahertz all the way to over 39 gigahertz, including the 42.5 gigahertz frequency band in China for millimeter wave deployment. The geographic needs are going to be different. That's going to put some pressure on deployments, and the needs are also fairly diverse, but we've been able to work with the different ecosystems to move this forward and make it a reality. Want to touch upon what's been going on in China specifically. IMT 2020 is the group that's promoting 5G in China, working with UE vendors, base station makers, operators, and we have been a big part of that. Keysight has been a big part of that. We participated in 5G trials, phase 1 through 3, and worked with the pioneers of 5G in China to help with system simulation, base station reference designs, phased array antenna research, massive MIMO, and also millimeter wave transmitter and receiver design. So these are things that we have solutions for and have worked with early 5G pioneers in China to move those forward. Now, phase 4 is next, and that's going to be pushed by operators, and real device development and manufacturing will be a big part of that. So we're excited to be partnering with the ecosystem in China to make 5G a reality in China as well. Now let me segue into some of the core challenges that we have understood the industry to be facing and how we've overcome some of those challenges. So much like legacy technologies, the previous wireless standards, every new air interface brings a new set of challenges. So in the case of 5G, clearly we want a very efficient communication system. We talked about the current network spending 2% of the world's generated power. So we have new waveforms and new modulation schemes. We know we have to provide enhanced mobile broadband and ultra-low latency type of features. So where's that going to come from? That's going to come by securing wider bandwidths at millimeter wave frequencies, which brings a new set of challenges. You have significant path loss now at millimeter wave frequencies. Those have to be overcome. And for that, you need to have a completely new antenna design for devices as well as base stations. So massive MIMO and beamforming come into play. Phased array antennas, miniaturized phased array antennas have to now be fitted into these devices. But the challenges are not just at millimeter wave frequencies. They're also present in the sub-6 gigahertz frequency range. Specifically, different numerologies. The stack has to be very tight from a latency perspective. And allocation schemes, frame allocation schemes have to be invented. There are new frame allocation schemes. And you also have to think about coexistence with legacy technologies when you're operating below 6 gigahertz. So those are some of the top challenges, and we'll go through each one of these in a little bit of detail. The first thing I would say is when you're designing a new communication system, it's all about the channel model, right? What does the channel look like? When you look at sub-6 gigahertz, that's fairly well understood. Sub-6 gigahertz communication system is omnidirectional, right? So I am surrounded right now by all of the legacy 4G, 3G, 2G signals. The only question is, how strong is the signal or how weak the signal is? But you look at millimeter wave, it's completely different. So if I turn this side, the signal may be completely absent. If I turn this side, I might be bombarded with signals. So it could be completely present or totally absent. Also, millimeter wave signals go through significant degradation depending on different types of surfaces. Glass, concrete, foliage. All of these brings new challenges and new ways to think about the channel model. So we've been working with many research labs and institutions to help create these new millimeter wave channel models. And if you don't have a good channel model, you can under-design or over-design the system. So that's number one. The second aspect, as we spoke about earlier, is the phased array antennas that we need to pull together, both on the device side as well as the base station side, to overcome the increased path loss at millimeter wave frequencies. So these phased array antennas form very narrow beams, so you can concentrate all of the power and overcome that increased path loss. So what this does is, these antennas are tiny, they have many elements, they have to now be integrated with the device. You cannot think about antenna design as an independent activity, from device design. And with these antennas being completely integrated, you don't have access to those connectors and test points. So the testing has to be done over the air. This is a significant shift for the industry, testing over the air. And almost all tests have to be done over the air. So you look at whether you're a chipset maker, whether you're an antenna designer, or whether you're making a front-end module or RFIC, or you're making the full device, you have different types of OTA tests you need to consider. So if you're a chipset maker, you're focused on modem performance, protocol characteristics, throughput, handover, latency. If you're a front-end module maker, you're focused on things like EVM, ACLR, spurious emissions. You have to have the link up and test for these parameters. And if you're a traditional antenna designer, then you have to think about EIRP and TIS. And finally, it's not enough if you test all of these subsystems separately. You also have to test it together as an integrated device. So you can see that in the past, while some antenna designers did some tests related to antenna design happened over the air, now all of these tests have to happen over the air, irrespective of who you are and what type of workflow you're focused on in 5G, UE, or G-Node B development. Also, if you're a base station maker, challenges are a little different. And UE maker, completely different challenge. Base stations are fixed. So you can put the base station in predefined test modes and let the beam go this way or that way and characterize. With a UE device, with a UE, it's a little bit more challenging, right? It's not only mobile, but the orientation could be very, very different based on the user. So you have to report some of the parameters like EIRP at every possible angle. Makes it a little bit more challenging. So I just wanted to tee that up mostly as a set of challenges that the industry is overcoming and has to overcome to make 5G a reality. And now I'll talk about what our approach has been, what Keysight's approach is to 5G, right? It's really simple. Two things. Donna touched on this earlier. Collaborations across the industry. Research labs, governments, consortiums, early market makers, and so forth. And then focusing on an end-to-end workflow approach. We're not just focused on solving one aspect of the problem, where we say, take this instrument, it's going to give you this measurement. We're done. No. We're looking at the whole workflow. You really think about how a UE design happens. It's usually a piece of software originally on a computer, and finally it needs to get into a system on chip and get integrated into a mobile. So that whole workflow needs to be looked at and mapped. So that's the approach that we have taken in 5G. So these collaborations have been going on for more than 4 years, for almost 4 years since we became an independent public company. These are the engagements that I can publicly speak about. So you can see that we're engaged with the universities, research labs, governments, consortiums like 5G, NGMN, 5GMF, IMT 2020, of course, the standards bodies, and all of the commercial market makers that's focused on early 5G trials and deployment. This has given us a lot of insight into what are the real challenges and problems the industry is going to have in making 5G a reality. So Donna spoke to the Pathwave concept. And this is a real example of how we've looked at some of those collaborations and looked at solving the problem end to end with a workflow-based approach. Oftentimes, to bring something like 5G to deployment, you have to have multiple departments within a company work together. And in fact, many companies have to work together. You can't look at each workflow as an individual silo, right? Usually each department kind of focuses on, I do this piece, I need this, and we're done. Well, that might be okay for that subsystem, but it doesn't give you the full end product performing well. So we've looked at some of the needs of the industry to stitch together the whole workflow to help the wireless industry achieve better time to market, more effectively from a cost point of view, and frankly, it saves a lot of trouble downstream where somebody thinks their part of the design is done, and then it moves forward and you have late discovery of problems, you have quality issues. All of those, I'm sure, resonate with you, and particularly in 5G, it's very important because of the technical complexity. So what we've done is we've kind of launched a world's first software platform that connects everything from a concept point of view to volume manufacturing through our software platform, Pathwave, that run on top of our instrument solutions to help connect the data analysis, the test results, etc., as things move through the workflow. The other real example that's been creating a lot of excitement in the industry is our 5G network emulation solutions. This is targeted at UE design and development. We have the world's first 5G base station emulator. We've also launched a channel emulator to provide those 5G channel models and real-world conditions. We know testing cannot be done in a cabled setup, so we have over-the-air, different type of over-the-air solutions. And finally, we need to make sure that once the design is completed, we have solutions that can scale and help produce these 5G devices inexpensively. So this entire portfolio is something that is commercial, and we're working with many lead partners in the industry to help with the UE design and workflow. As I mentioned, the UE design usually starts with a piece of code sitting on a computer, and then it gets simulated by FPGAs and other DSP platforms. Then it moves from there to a system on chip. System on chips get integrated with other system on chips to pull together into an integrated device, and which then has to be volume manufactured. This whole end-to-end workflow is something that we've been able to help the industry with, actually by participating in the pre-standards version of 5G, and we're able to bring that to 5G NR as well. So those are a couple of examples of how the collaborations with the industry and an end-to-end workflow-based approach has really helped us work with our industry partners and customers to make 5G a reality. So those are a couple of proof points. These are recent press releases that we have had with many of the folks in the industry. You can see that we've helped the industry from anything like base station reference design to phased array antenna research to modem test to over-the-air tests, and also in the creation of specifications for trials. So we're kind of engaged in the whole arena of 5G test and 5G challenges that the industry is facing. Just a few months ago, we announced and demonstrated at Mobile World Congress 2018 a full-blown modem capable of doing 4 gigabits per second, aggregating 8 carriers. And this test was done over the air, and it was publicly displayed at Mobile World Congress in 2018 using the Qualcomm chipset. Here's another example. Last year, we were chosen by Verizon for their 5G fixed wireless access trials. Again, a full network emulator solutions with over-the-air test. We're also working with them on creation of the specs for trials. And this actually has helped not just our customers and Keysight, it's actually helping the whole industry get a sense for how we can make 5G happen. Coming to China, we have a few examples. We were asked to participate in the 5G trials, phase 1 to 3. We did the specifications for IoDT. We demonstrated that with Huawei first, and then later on did it with Nokia Ericsson as well, and the Tong as well, and for which we were recognized by IMT 2020. We've also been recognized by the Global TDD Initiative over the last couple of years for contributions to 5G. First for our channel emulator solution for 3D massive MIMO design and development, and most recently this year for UE emulation of NB-IoT devices. So we're really proud and happy to be participating in and furthering the whole industry forward in 5G deployments. So I'm going to leave you guys with this slide. This was a statement made by Lord Kelvin. And he said this, right? There's a lot of hype. There could be a lot of exaggerations. But the only way to find out is to measure things. You have a theory, you have a hypothesis. You want to test it. You want to validate it. You want to see how much of this is true. And that's really Keysight's purpose. We can look at the whole 5G vision and then see how we validate the different assumptions, the different challenges, the different test cases, and see how much of that can be brought to reality in a cost-effective way so end users and the whole industry is benefited. So with that, I will conclude. Clearly, Keysight is here to help this whole industry, the commercial communications wireless industry, to deploy 5G. Hopefully, you've seen many examples of how we've done that over the last few years, and it's very exciting to see all of you here, and I hope you take advantage of your presence at Keysight World in Taipei today. Check out all of the different booths, connect with many of the experts, and we look forward to helping you today and helping you in the future in making your 5G dreams real. Thank you.